Hello geometry students, this is Mrs. Hefty here. Today we're covering section 2-4, which is on deductive reasoning. Earlier we talked about inductive reasoning. Remember, that was when I got that stomach ache. I'd eat pizza, I'd get a stomach ache, I'd eat pizza, I'd get a stomach ache, and then I started to come to the conclusion that every time I ate pizza, I got a stomach ache. Well, when you use deductive reasoning, you are using facts and rules and definitions or properties to reach conclusions. So we're going to use deductive reasoning when we actually go and do our proofs in the next couple of sections. There are two patterns that we use in deductive reasoning. The first one is called detachment, and the second one is called syllogism. During the class hour in your teams, you were supposed to look at a number of examples and then try to find the patterns for detachment and syllogism. And now I'm going to go through those patterns. Detachment. If you had a boat and it detached from the dock, it would separate, wouldn't it? And so that's exactly what detachment is in deductive reasoning. First thing you have is a sentence. If-then statement, if P then Q, and then they become detached or separated. So then you're going to take the first part, the hypothesis, and state it separately, and then you take the conclusion and state it separately. So it reads if P then Q, and then you state the if part by itself, and then you state the Q part by itself. And that's detachment. Detachment is to separate. Now, I do have an example here underneath this blue piece. If you are a Hillman, then you are from Platteville. Then I'm detaching, and I'm using a specific example here. Mary is a Hillman. So see how it's detaching? It's taking the if part and separating. And then I'm going to take the then part or the Q part, and I'm going to use Mary again. Mary is from Platteville. So that's an example of detachment. So you have if P, then Q, then you specify an example of P, and then you use that same example with the Q. Syllogism uses an if-then statement again first, then another if-then statement, but notice that if P, then Q, that the second conditional statement or if-then statement begins with what you've ended with here. And then your third statement or your conclusion is taking the beginning or the P part and using the hypothesis or the conclusion of the second one. Again, I'm going to give you an example. Let me pull off that blue. If you are a Hillman, then you are from Platteville. My second statement, okay, so this would be my P, this would be my Q. In my second statement, notice that I'm beginning with my Q here. If you are from Platteville, then you are from Wisconsin. So this is a new thing, that would be my R. And then my conclusion takes the if part, if you are a Hillman. If you are a Hillman, then you are from Wisconsin, which is the R part. Then you are from Wisconsin. Then you are from Wisconsin. So if you want to pause the video and write those two examples down, I strongly suggest it. I think that's going to help you as we move through this video. In the next part, we have a number of examples. It says determine whether the stated conclusion is valid based on the given information. If not, write invalid and explain your reasoning. And at this point, we're not going to have to write any third conclusions. The conclusions are already going to be there. In examples farther down, we'll have to write those. So number one says, given if a number is divisible by 6, then the number is divisible by 3. So I have an if-then statement here. So this is if my P, then my Q. And then I have 18 is divisible by 6. Now do you people see here that this is the P part, a number divisible by 6? And then I'm specifying exactly what number 18 is divisible by 6. So this is the P, and it's a specific example related to the P. And then notice here 18 is divisible by 3, and that is the Q part. The specific number is 18, and it is divisible by 3. So this example is detachment. Notice how the if-then statement is becoming detached, separated, and then I'm using specific examples, which are my 18. Let's take a look at example number 2. Given if a pet is a rabbit, so this is my P, then it eats carrots. This is my Q. Okay, now Jeannie's pet eats carrots. Now that is the Q part, people. Do you see that? They are separating, but the P has to happen first, then the Q. Q is happening here. It's supposed to be PQ, PQ, and I don't have that pattern. I have P, Q, Q. So this would be an invalid statement, an invalid conclusion. Let's look at example number 3. If a hen is a Plymouth Rock, so this would be my P, then her eggs are brown, that would be my Q. Berta is a Plymouth Rock hen. Okay, so that is the P. So once again, I'm thinking detachment because I have a P, Q, and then I'm having P again. Now I need to look, is my conclusion the Q? It is. All right. Now, had I written something like Berta's eggs are all broken, then this would be invalid because I'm supposed to have brown at the end, and I do. But if it had said Berta's eggs are broken, then that would be invalid. This is detachment. This is detachment. It's following the pattern PQ, PQ. In our next section, it says, use the law of syllogism or detachment to draw a valid conclusion from each set of statements, if possible. If no valid conclusion can be drawn, write no valid conclusion and explain your reasoning. Okay, so our example number 4 reads, given, if a dog eats super dog food, he will be happy. All right, I love it when they have it in if-then form because then I can identify my P and my Q pretty easily. This is my P and this is my Q. All right, Rover is happy. Okay, this is not an if-then statement and I cannot make it be an if-then statement. Happy has to deal with the Q. So this is the Q part. I was thinking that this was detachment because I'm separating these two here. I have super dog food and then I have a happy dog here. But this Rover is happy is the Q and it's supposed to go P, Q, P, and then Q. So in this example, no conclusion can be drawn because this here, this statement should be dealing with the super dog food is what it should be doing. Let's look at number 5. You are given, if an angle is a right angle, then the measure of the angle is 90 degrees. Okay, so I'm thinking this is the P, this is the Q. I still have my if-then statements. Now, I have another if-then statement. If two lines are perpendicular, then they form a right angle. So I have two if-then statements back here at the beginning. Looking back on my notes, syllogism had if-then statement, if-then statement, if-then statement. I haven't done any syllogism ones yet, but this one here that we're working on, people, it looks like a syllogism one because I have if-then and then I have another if-then. Now I caution you because remember it went P, Q, then Q, R. Here we're talking about the measure of an angle being 90. And here I'm talking about perpendicular. These two, this is supposed to be matching here, and it is not. So this is a no conclusion can be drawn because it should be saying if two lines have 90-degree angles or if the angle measure is 90 degrees. And it does not read this is Q and this is not Q, so there's no conclusion. Let's take a look at number 6. A square is a parallelogram. A, B, C, D is a square. Now first off, this example here does not have it in if-then form. It's not a conditional statement. So I probably can see if it is a square, then it is a parallelogram. So I can write it that way. And I have it written right here. If it is a square, then it is a parallelogram. And I'm just thinking that out loud. I could write that down. If it is a square would be my Q, then it is a parallelogram. I'm sorry, is P. If it is a square, that's my P part. If it is a parallelogram, that is my Q part. Now when I come over here, I say A, B, C, D is a square. It's detaching. See how it's separating? Syllogism goes if then, if then, if then. Detachment has an if-then statement that does a separation, a detachment, and the P has to detach first, which we're doing here. Do you notice that this matches? This is square and that's square. So this is giving a specific example of a square. ABCD is a square. So now my conclusion has to have the Q here, which deals with parallelograms, and it has to use the specific example ABCD. So it's going to read ABCD is a parallelogram. So I'm using detachment, and my specific example is ABCD, and Q is parallelogram, so ABCD is a parallelogram. I have one more example that you don't have, so you may need to pause the video and write this example down, and then I'll talk about it. Okay, so number 7 says, Algebra 2 students have taken geometry, and geometry students have taken Algebra 1. The first thing I strongly suggest is you need conditional statements. Those are if-then statements. And maybe in this example you can see what the if-then statement is, and you don't need to use the magical words if and then. But for that first one, if you are an Algebra 2 student, then you have taken geometry. So I'm rewriting it so that I have my magical if-then statement there. Okay, so I can see that this is my P and this is my Q. Now my second statement reads, geometry students have taken Algebra 1. So I think I can write that in an if-then statement. If you are a geometry student, then you have taken Algebra 1. And so I'm going to write that down, and there it is. Now, I have two if-then statements, so I'm thinking this is syllogism. I need to take a look here. Here's my Q. Remember, your second if-then statement must begin with your Q, and this one does. Then you have taken Algebra 1. And this is a whole new concept. I have Algebra 2, I have geometry, now I have Algebra 1. This would be my R. So this is the pattern for syllogism. I have my P, then I have my Q, and my beginning second statement starts out with my Q, my geometry students, and then I come through with my R, which is Algebra 1. Now I have to take, for my third statement, I take my P, and then my R, right? So that's going to read, first off I'm using syllogism to help me solve this, and it would read, if you are an Algebra 2 student, then you have taken Algebra, not exclamation point, but Algebra 1. So we've learned our deductive reasonings, our law of detachment and syllogism. You students have an awesome night, and I'll see you in class tomorrow.